this is 9, 9 here, and we're looking to evaluate the complex numbers here at A and B and put the results in polar form. So polar form means we want a radius and an angle here, right? That's the form that we're looking for. So let's get started with this first one, part A. And to get started on this, we first need to work on transforming the 2 plus j into polar form. So we will work on transforming 2 plus j into polar form. So to transform that, our radius is going to be equal to the this here. Now you can think of this value as a vector, and you have 1, 2 in the real direction, and then in the imaginary direction you have 1. So we have 2, 1, this looks like a vector here, and we're looking for the length of this. And to do that, we need to use the Pythagorean theorem, 2 squared plus 1 squared and the square root of that. So that is the square root of 5. Now to find this angle, and we'll call this angle theta here, to find this angle theta, we know that the tangent of theta is equal to the height 1 divided by 2. Opposite over adjacent, 1 divided by 2. And by doing that, we find that, let's perform that calculation. Theta comes out to be, that means theta is 26.57 degrees. Okay, so we have r and we have theta. Now we need to do this operation here. So we have 3 at an angle of 60 degrees, and then we divide that by our square root of 5 at an angle of 26.57. Now to do this calculation, let's take a look. Let's see if I can grab this quick. We have these sorts of what we can use. So what we are doing is division here. So we have R1 divided by R2 at an angle of phi1 minus phi2. So that is 3 divided by the square root of 5 at an angle of 60 degrees minus 26.57. So that comes out to be 3 over square root of 5, 60 minus 26.57. That's at an angle of 33.43 degrees. We have that. So that is this here. And to add to these values here, we need to convert this into Cartesian form. So we need to change this to Cartesian form. So we need our imaginary and real components. So we have something that's 3 square root of 5 cosine of 33.43 plus j 3 divided by square root of 5 sine of 33.43. So by doing this, let's do that calculation. cosine 33.43. That is 1.12 plus 33.43 times 3 divided by let's see, and that comes out to be J.739. So we just converted this value into a Cartesian form. So now we can add these two together. So we have 6 minus J8 plus 1.12 plus J 0.739. And these values then come out to be 7.12 plus J, well, this is negative 8. So that is minus J 8.739. So that is 7.261. Okay, so we have all of this done. We have this answer, and now we just need to multiply it by this value. So we need to then flip this into polar form. So moving this to polar form, we have r is equal to 7.12 squared plus 7.261 squared. And the tangent of theta is equal to negative 7.261 divided by 7.12. Okay, so this value of r, 7.12 squared plus 7.261 squared, square root of that, this is 10.169. And this value here, theta, comes out to be 1 divided by 7.12 comes out to be negative 45.56 degrees. Okay. So now we have this in polar form, and we can now multiply by this. So we have 5 at an angle of 30 degrees, and we're multiplying by 10.169 at an angle of negative 45.56 degrees. So we will be using this equation here, where we multiply the radii together and then add the angles. So we multiply 5 times 10.169, which is 50.8, and the angle is then 30 plus this value, which is going to be negative 15.56 degrees. And that is the solution for part A of the problem. Now we'll continue on to answer part B of this question, part B, where we have these values. So let's get a new sheet. Let's take a look, and then, so what we'll be doing for part B is we'll be looking at 10 at an angle of 60 degrees, and then 35 at an angle of negative 50 degrees, divided by 2 plus J6, and that's minus 5 plus J. Okay, so we'll start out by looking at the denominator here. This is the denominator. This is called the numerator. This is the denominator. So we'll take a look by starting with the denominator, and we can add these together. So we have 2 minus 5, that is negative 3. And then we have 6 minus J, which comes out to be J5. So this is the value here. And we'll take this and we'll convert it to polar coordinates. So if we convert that to polar coordinates, right, so we have something that is, this is the real and this is the imaginary. So we have 1, 2, 3, and then 1, 2, 3, 4, 5. So something like this. And we're looking for R, and then we're going to be looking for this value here, this angle. So R is going to be equal to the square root of negative 3 squared plus 5 squared. That's 25, that's 9. Let me rewrite that. That's negative 3 squared plus 5 squared. Let's write it that way. So that's 25 and 9, and that is the square root of 34. So R, this value is square root of 34. And this angle here, theta, tangent of theta, is equal to this, to 5 divided by 3. And so theta comes out to be, let's see, 59.04 degrees. But that's this angle. We actually want this one here. We want this angle, phi. And so that is going to be equal to 180 minus this 59.04. So that comes out to be 120.96. Okay. So let's now rewrite this equation. So we have, starting at the beginning, we have 10 at an angle of 60 times 35 at an angle of negative 50 degrees divided by this square root of 34. And let's just get a value. What is the square root of 34? That's 5.83. So let's just write 5.83. 5.83 at an angle of 120.96 degrees. So this is our equation. Now let's work on the numerator. The numerator here. And so we multiply these two together. So that's 350. And we add the angles together. That is an angle of 10 degrees. And then we have divided by 5.83 at an angle of 120.96. So we divide these, 350 divided by 5.83, which is 60.0. And then we subtract those, that is 10 degrees minus 120.96 degrees. So 10 minus 120.96. So that is 60.0 at an angle of negative 110.96 degrees. So that is the solution for part B.